Good day, everyone. Before I start, let me introduce myself. By the way, I am Sophia May H. Amarante, BSBA, major in Financial Management, and I'm currently studying at Kapalong College of Agriculture, Sciences, and Technology. So, I'm here to discuss the lesson of mathematics of investment, which is simple interest, simple annuities, and general annuities. So, let's discuss first the simple interest.
Simple interest. The simple interest is a way to calculate the interest charged or earned on a principal amount over a period of time. And these are the formula of simple interest. I equals simple interest in pesos. P equal principal in pesos. R equal rate or percent of the principal which is to be paid per unit of time. T equal units of time usually expressed in years or fractional parts of a year. So this is the example of simple interest. Find the interest in amount on 550 at 5 and 1/2% simple interest for 4 years. This is the solution. This is the formula. I is equal to P times R times T. I is equal 550, which is our principal. The rate is 5 and 1/2%, then you must divide 1 and 2. After you divide, add the 5, then equal, so the result is 0.055. Our time is 4 years, so let's multiply 550 times 0.055 times 4. So the result is 121. Let's proceed to final amount. So our formula for this is F equal P plus I. You must put 550 as our principal, then add 121, so the final result is 671. Let's proceed of simple annuities. The simple annuities is a series of equals payments made at regular intervals over a specific classification of simple annuity. Ordinary annuity, an annuity in which the periodic payments are is made at the end of each payment interval. Annuity 2, an annuity in which the periodic payments are is made at the beginning of each payment interval. Deferred annuity, an annuity in which the periodic payment is not made at the beginning nor at the end of each payment interval but some later date. Notation: S equals sum of amount of an annuity. A equal present value of an annuity. RS equal periodic payment of the sum. RA equal periodic payment of the present value. T equal term of an annuity. R equal rate of an annuity. N equal number of conversation periods for the whole term. M equal number of conversation periods per year. I equal interest per conversation period, RM. AO equal ordinary annuity. A2 equal annuity 2. AD equal deferred annuity. So, were we going to solve for the amount and the present value in the annuity? We are going to use formula which is S equal RS angle I. A equal RA and angle I. So later on, we are going to use the table number 5 and the table 6 for our A. And for us it is the amount we're going to solve the amount and for a present value. So this is the example of simple annuities. Find the amount and present value on annuity of 270 payable every end of the month at 9% compounded monthly for 5 years and 5 months. So we are going to identify the given in our problem. So we have here a R, which is the periodic payment of 270. We have our rate, which is 9%. For our M, we have here monthlies. So in 9 years, we have 12 months. And also, we have our time. We have 5 years and 5 months. So I is equal to R over M, which is 9 over 12, is equal to 3/4%. For N, we have time times M, which is for time. We have here 5 years and 5 months and times 12. So let's compute for our N. So we have 5 divided by 12. We have 0.4116. Add 5, so 5.416 times time 12, we have 65. And we are going to substitute with our formulas. First, we are going to solve for the amount. So we have S is to RS and angle I. S is equal to per hour, we have 270. Our N, we have 65. And angle I, which is I is equal to 3/4. So S equal to 270. So we are going to look it in table 5. We're going to look for the 3/4 of 65. So we have the amount of 83.370852. So we can solve for the amount, which is S is equal to 270 times 83.370852 is equal to 22510.13. So this will be the amount, and we're going to solve now the present value. A is to RA and angle I. Same process, RA, we have 270A. For N, we have 65. At angle I, 3/4, so A is equal to 270. Same what we did at table 5. For present value, we're going to look to table 6 for the 3/4 of 65. We have the amount of 51.296257. So let's compute. We have 270 times 51.296257. We have the final amount of 13849.99. So let's proceed for the final topic, which is general annuities. A general annuity is a financial arrangement where regular payments are made or received at equal intervals over time. There are three terminologies. First, general ordinary annuity. The first payment is made at the end of each payment interval. Second is general annuity due. The first payment is made at the beginning of each payment interval. And third, perpetuities, a series of periodic payments which are to run indefinitely. Notations. A equal present value of an annuity. S equal final value amount of an annuity. R equal periodic payment of an annuity. RA equal periodic payment of the present value of an annuity. RS equal periodic payment of the final value amount of an annuity. N equal total number of compounding periods for the whole term, T times M. M equal number of compounding periods for 1 year. I equal rate per compounding period, R over M. C equal number of months in compounding period. P equal number of months in a payment interval. K equal number of compounding periods in a given payment interval, P over C. So this is the formula of general ordinary annuity. So this is the example of general ordinary annuity. Find the present value of an annuity of 550 every end of the 3 months for 10 years if the interest rate is 4% compounded annually. So we are going to identify the given in our problem. So we have R equal 550, R equal 4%, M equal 1, and T equal 10 years, P equal 3 months, C equal 12 months, I equal R over M equal 4 over 1, equal to 4%. N equal T over M equal 10 divided by 1 is equal to 10. K equal P over C equal 3 over 12 is equal to 1 over 4. And we're going to substitute with our formula. First, we're going to solve for the amount A equal R 1 over SK angle I and EN angle I. A equal 550, 1 over S 1/4 angle 4%. So A10 angle 4%. A equal 550. So we are going to look it in the table 7 or 8. We are going to the 1/4 of 4%. So we have the amount of 4.059510. And we're going to the next table to look the A10 angle 4%. So we have the amount of 8.110896. So we can solve the amount, which is A is equal to 550 times 4.059510 times 8.110896 is equal to A equal 18,109.44.